Hello students, today's topic is nesting of loop in infinite loop in C. So first we will discuss nesting of loop and then infinite loop in C. So what is a nesting of loop? When we place a loop inside another loop, that is called nesting of loop. So any number of loops can be nested, and we can any type of loop can be nested in any other type of loop. For example, we can put while loop in a for loop, or a for loop in a while loop, or while in a do while, and so on. So placing one control structure into another structure is called as nesting of control structure. So when we place one control structure into another control structure is called nesting of control structure. So nesting of control structure adds to the complexity of the program. So our program become complex when we when the nesting of control structure is done. But there are many problems that cannot solved by using single loop or single control structure. So there are many complex problems which cannot be solved by using a single loop. So we use nesting of loop. So there can be nested loops like nested ifs. So we have already discussed uh, nesting of if, and nesting of if else. So the loops can be nested similar to nested ifs. So any one control structure can be embedded into other control structure or within same control structure. So syntax of the nesting, for example, while loop, while condition 1, if this condition is true, then while condition 2, and if this condition is true, condition 2 is true, then the statements will be executed. So for execution of the statements, we require statement 1 and statement 2 to be true. When statement 1 is true, then only control goes to statement 2, and when statement 2 is true, then when the condition 2 is true, then the statements will be executed. The loop index variables are required for handling two loops. So we require the loop index variables. One loop is called as outer loop, another loop is called the inner loop. This while loop is called outer loop, and this while loop is called inner loop. So there are two separate bodies of each inner loops and outer loop. So body of this outer loop is from this braces to this braces, and body of the inner while loop is from here to here. So if the condition 1 of the outer loop is true, then the control is transferred to inner loop. So when the condition 1 is true, then the control is transferred to condition 2, whereas separate condition 2 is tested, where we test the condition 2. So similarly, we can nest for loop for initialization 1, condition 1, and increment or decrement. Then we can nest another for loop in it, uh, condition 2, initialization 2, condition 2, and increment 2 or decrement 2, and the statements. So when the outer for loop, the condition of the outer for loop is true, then the control goes to the inner for loop, and the condition of the inner for loop, that is condition 2, is true, then the statements will be executed. So there is no limit that how many loops can be nested in one another. We can nest as many loops as we require, as our program logic requires. So this only depends upon the complexity of the problem. So also any type of loop can be nested any other type of loop. So we can nest any type of loop in any other type of loop. There is no restriction. So let's consider a program. For example, we have to print uh, this structure. So here I have included two header files. I have initialized a integer variable I with 0. I have declared two integer variables j and n. So enter the limit. So limit, for example, I have entered here 6. So for upper loop, value of I is 1. I is initialized with 1. So value of I is 1. So I is less than equal to 0. Yes, true. I is less than equal to 6. Control goes to inner loop. J is initialized. So value of j is 1. So j is less than equal to I. Yes, j is equal to I. I is 1 here. So this is true. J is equal to I. J is equal to 1. So print I. So 1 got printed. Then again, now I becomes j becomes 2. So this condition fails, becomes 2 is not less than equal to 1. So again control goes here. Now I becomes 2. So value of I becomes 2. So 2 is less than equal to 6. Yes, condition true. Then control goes here. J is 1. 1 is less than equal to 2. Yes, true. So print I value of I is 2. 2 got printed. Then again j is incremented, value of j becomes 2. So 2 is less than equal to 2. Yes, true. So here again print I. So again 2 got printed. then value of j becomes 3. So j is less than equal to 2, no, condition fails. So control again goes to this loop, and so no, value of I becomes 3. So 3 is less than equal to 6, yes. So again here 3 got printed, because j of value of j is 1, then 3 got printed, then it becomes 2, then 3 got printed, then it becomes 3, then 3 got printed, then it becomes 4. Then this condition fails, again control goes to here, the outer for loop. Now here value of I becomes 4, 4 is less than equal to 6, true. Then again j is initialized by 1, so j is less than equal to 4, yes. So 4 got printed, then j is value of j becomes 2, 2 is less than equal to 4, yes. 4 got printed, then value of j becomes 3, yeah, so 3 is less than equal to 4, yes. So 4 got printed, then value of j becomes 4, so 4 is less than equal to 4, yes. So 4 got printed, then value of j becomes 5, 5 is less than equal to 4, no, condition fails. Then I goes here, the value of I becomes 5. So in this case 5 got printed, then value of I becomes 6, then 6 and 6 becomes got printed, then value of I becomes 7. So 7 is not equal to 6. So this outer loop fails, the control goes out of this outer loop and gets CH. See, this is the output of this program. Similarly, in another program, for example, we have to find first and prime numbers. So here I have included two header files. I have declared integer variable j, count and initialize with 0, num is initialized with 2, remainder rem is initialized by 1, and limit. So how many numbers we want to print? For example, limit. For example, in my first run I have entered 5. So 5. So count is 0. 0 is less than equal to 5. So I have this is while loop is outer loop, and for loop is the nested inner loop. So here two different loops are used. So value of j is 2. 2 is less than equal to num minus 1. What is num? Yes, this condition fails. So here remainder not equal to 0. So value of num got printed. Value of num is 2. So first is 2. Then again value of j becomes 3. So 3 j becomes 3, 3 to num minus 1. So the simple logic is, what is a prime number? A prime number is a number which is divisible by itself and 1. So in this logic, we are trying to divide the number by from 2 to num minus 1, and if the remainder is not 0, then then we will print that number. If the remainder is not equal to 0, and we will, here I have included a counter count. It will count the numbers, that how many numbers we have printed. This is how we can find the n prime numbers. Now infinite loop. So what is infinite loop? A loop which never terminates, which runs on indefinitely, is known as infinite loop. So a loop that repeats itself and never terminates is called an infinite loop. So infinite loop is loop which never terminates. So most of times we create infinite loop by mistake. However, this does not mean that the infinite loops are not useful. So many times we create the infinite loop by mistake, uh, um, but that does not mean that these are not required. Sometimes we require the infinite loop. So infinite loops are commonly used in programming that keeps running for a long period of time. So when we want a program to run longer period of time, so we use infinite loop, and we will stop the loop using some other source like the web server. So some examples of infinite loop. For example, I have initialized I with 1. So I is less than equal to 10, print I. So value of I is 1. 1 got printed. Then again I have not incremented I, so again 1 got printed. Again 1 is less than equal to 10. Again 1 is less than 10. So it runs infinitely, because I never becomes more than 10. So this condition will always be true. So always 1 got printed. In other, for example, I have initialized I with 1. So while I is equal to 10, but this is assignment operator. So I value of I becomes 10. So any positive value is true. So 1 got printed. I print the value of I. 1 got printed. Again, this is true. Then this got printed again. So it will always be true. So 1 always got printed here. Again here I have used a for loop. For I equal to 0, I is less than 5, I minus minus. So value of I is 0. So yes, 0 is less than 5. Print the value of I. Value of I becomes printed here 0. Then I minus 1. So value of I become minus 1. So minus 1 is less than 5. Minus 1 got printed, and so on. So it is it will always be less than equal to 5. So the value 0, -1, 0, 2, -2, -3, -4, and so on, these always got printed here. So these are the some examples of infinite loop. So this is what I have today. And the nesting up loop, the loop inside a loop is called a nesting up loop. So we can nest as many loop as our program logic required, and also we can nest any type of loop inside any other type of loop. So there is no restriction. Also, infinite loop, a loop which never terminates, is known as infinite loop. So sometimes we require these infinite loops to run our program for a longer period of time. This is what I have today. Thank you.